All right, so a couple notes just based on some stuff I heard in our breakout group was one, I know everyone's feeling the pain of making data sets. It is definitely a big challenge. Um, One thing I'll note is that if you are concerned about using Colab or just like not really there yet, you can use Runway. So I know Kelly has used Runway. I know Anya previously used Runway. I'll post a link to training in Runway. Um, the truth is, I don't find the results as good in Runway for a couple reasons, but it does exist if you're interested in it. Also, it's just easier. So if you're just like, I just want to train a model and like get over that hump, then I would say like start there. That's always a good option. So I'll post a link to that in our class notes for after class. But if you do want to do that, check that out. Also, if you did train your model in Runway, so Anya and Kelly, I recommend during our break checking out the video on how to download your model because we'll be using Colab just to do the interpolations and other things. So I would check that out just so you can download it and then upload it to Colab and use it that way. I do have some videos on how to use the latent model stuff directly in Runway, which is like a nice GUI, but again, I kind of find that it's a little limiting, and we'll talk about why the limits are the way they are, in a little bit when Leah goes over the latent space stuff. Yeah, so those are probably the two big things. The other thing I'll say is if you haven't trained a StyleGAN model, I would definitely recommend it between now and next week because next week we'll be doing pretty much everything will be StyleGAN related. We'll look at a couple additional cool tools to use. Leah's going to do a touch designer demo. So we'll look at some fun things to do with StyleGAN. And I also just generally find that it is like the highest sort of bar. So if you can do it by the end of this class, like Leah and I can give you help with anywhere you get stuck. Other things are a little bit easier, quote unquote, but just in general, if you can get over this hump, you can pretty much do anything in Colab. So it's definitely like the big challenge. Cool. So I want to quickly jump into like doing some inference stuff just because we do not have a lot of time left. So I'm going to quickly share my screen and just sort of jump into our demo for today. All right, everyone can see my screen, yes? Okay. So we're gonna cover mostly inference today. I'm gonna quickly go through NFP and Munit, and then Leah is gonna pick up and do a bigger thing in StyleGAN. One thing to note is that like I'm gonna show you pretty much everything you can do in NFP and Munit today, and like StyleGAN is way more. There's like so much more we could do about it. In fact, I'm thinking about maybe teaching an additional class that will cover more StyleGAN stuff in the next couple weeks. I'll have more ideas on that in the near future. But just know that there's so much you can do with StyleGAN because of the way the model works. Whereas we're a little limited with NFP and Munit because it just takes an image input and there's only so much you can do with an output from there. All right. So NFP inference. So one thing to note about this is I'll basically just describe a couple of these things and then we'll talk about how to actually use them in Colab. So one thing we're going to look at is we're going to look at using this thing called which epoch, and that will say like which version or which iteration of the model do we want to use. And I think I touched on this briefly, but those epochs are numbered. So in most cases, they'll go from 0 to 200. And for most of us, if you use like the default that I recommended, it'll go 5, 10, 15, 20, all the way up to 200. And here's two examples here. So you'll see along the top right, I believe this is probably like 25 or 50. And down here is probably like 300. So you can sort of see that like the early examples are much more glitchy. They're much more sort of artifacty, very machine looking. And the later ones are going to look a little bit better. I mean, none of them are going to reach realism, but they're just going to look better. So I also have a folder of examples of this particular model where it goes from like, I think 25, 50, all the way up to 400. So you can look at like, if you train it even longer, does it get better and better and better? And it does, but you'll sort of see like from 0 to 200, you get a lot of change. And then from 200 to 400, it's like very subtle. It tends to like not get much more or like very little bit differences. And like I said, some people train it up to 1,000 epochs, which is pretty wild. That's a lot of days. But the motion does get even better and better. So we'll look at how to use this in just a minute. But just know that this is sort of the first thing you're going to do is you're going to say, which epoch do I want to work off of? Next, there is you can pick what frame you want to start from. So remember that the way this model works is it takes in your input frame. So you assign it a frame. It takes that image, and then it tells you what the next frame should be after that, right? It predicts the next frame. And then it takes that frame and it predicts the next frame off that. So what you'll find is that there's subtle and kind of interesting differences depending on what your very first frame is, which is what you choose. So this is start from. We're going to provide it a particular path to an image. So it takes in an image, and that's what's important to remember is start from takes in an image. So in this first example, I fed it an image that is pretty straightforward in terms of it's just a image. This is actually not from the training set. This is actually an image from outside of this training set. And you'll see that the first thing it sort of does is it destroys this rock in the middle. So what you start from, even if you start from a different image or a different data set, will influence the rest of the video. And then this one, let's see what's in this one. Yeah, so this one, we're going to feed it a completely different image. And you'll see it doesn't really do that much. The first couple of frames are pretty different, but then it immediately sort of goes back to its waviness. If I were to train this for maybe 1,000 epochs, that first frame might hold on a little bit longer, but eventually all these things decay to the data set you have. But just feeding it a different input can lead to different results because it's sort of like a feedback system, right? Where it starts is where it moves to. So I recommend playing with this and just sort of seeing what you get. You can also kind of do some cool transition effects in some ways. All right, and another thing we can look at here is a thing called zoom level. So I believe Mackenzie was asking about this previously, which is how did I make one of my videos that does sort of this zooming sort of thing, and that's this feature called zoom level. And what zoom level does is for every frame it takes in, it crops into the image a little bit and then resizes it, so it zooms into the image. And whatever you set the zoom level as equals a pixel. So if you do a zoom level of 1, it's just going to crop in 1 pixel from the image. And if you do a zoom level of 10, it's going to crop in 10 pixels. And if you do a zoom level of 300, it's going to crop in a lot, and you're going to get sort of this tunneling effect. Yeah, so it's it also feels like split scan from Space Odyssey 2001, that sort of thing. David asked if negative is possible. I don't think negative is possible because you would have to give it some sort of what would the content look like, which I guess we could do. We could do some padding it or replacing that with data, but it's not set up for this library. So yeah. Yeah, you could do outer pixel protection. That would be a different model that would feed into this one. It'd be interesting. So those are the 3 big things to play with inside of Colab. So let's just take a look at how this works in Colab. So I've already opened up the notebook. I've gone ahead and just already connected to so check to see I'm on a V100. I've already linked to Colab, and I've already moved into that folder just to save myself a little bit of time because I know we're going to run short here on time today. So one thing I note is if you made a copy of this notebook, you might want to come back and just open this link again. There's another cell that I've added here, and you should probably run this cell the very first time because basically this will update some of the code. So basically you've got your GitHub repo that's sitting in Google Drive. If you just run this cell, it should update these files. Now it's not a perfect system, so people might run into issues. If you do, let Lee or I know, and we can try to debug it. But basically, this will just update some of the stuff in your Drive code. Okay, so you've already got your model trained. One of the things that you need to know is those model files show up in NFP Colab Pix2Pix HD checkpoints. Now I mentioned this before. There is a funky bug or something going on in Colab where if you try to look at your checkpoints folders in Colab in this experience, it will look empty. It is not empty. There's just a thing where they hide all the files in there. So I recommend checking out in Drive the files. So when you go to checkpoints, you'll see all of the names of these files you made, those project names. So I have a ton of projects in here, but we can just look at this one, which is the demo that I've been showing, which are those waves. And in here are, most of you will have at least these netd and these netg files, and these netd and netg have a number in front of them, and that number corresponds to epochs. So most of you probably don't have 400 in here. You probably have it stops at 200, or actually what it probably does, it stops at a thing called latest. So that which epoch that you're going to feed into the model, that number needs to correspond to a file that exists here. So if I were to ask for which epoch 397, and I don't have a 397 here, so it's going to throw an error. So make sure that whatever which epoch you're looking for corresponds to both the project name and that there's a number corresponding with that epoch here. So let's take a look at this in the code. So down here we've got generate videos. So we'll pass in this command, which will be Python generate video.py name. So names is the project name. I generally recommend that you name this the same as what you named it during your training. That just keeps it like the same mentally. So just do that. Your data root will always go again to that data sets, and then this exact same path will be used here. If you do not use the exact same path here, I think it might throw an error. So just know that. Next, frames per second. So when we generate the video, this is going to say how many frames per second do we want. I would generally set this to be the same as whatever your input video was. So if you had a 30 frame per second input video, you might want to set it to 30. If you had a 60 frame per second video, you might want to set it to 60. That just keeps the speed semi-consistent. It's always a little weird, but that just like feels a little bit different. Feels the same. Next is how many. This is how many frames do we want to produce. So if you take this number and divide it by this number, that will equal how many seconds long your video is. So for me, for this demo, I'm gonna make this shorter just so that we're not standing here waiting for this thing to generate. So I'm gonna set this to be a 10-second video. And then here's the which epoch that it takes. So by default, it takes latest. And latest will always look for this file. It'll look for latest netg. So I can change that, and I can set it to any number that I see here. So, I could set this to 50, I could set it to, 110, but I can't set it to 112 because 112 doesn't exist. So just remember that. That'll be an error if you don't. So that's the key to remember with this. So I'm going to set this to 100, and then I'm going to run this. And while this runs, I'm going to go ahead and get set up for the next thing. So this will spit out a bunch of code. These are basically all of the variables in your code. Most of these we never set because they're all defaults, and we're mostly fine with the defaults. This will then look at sort of say, okay, so what it's going to do is it's going to take from your test frames. And if I look in test frames, so let's go into NFP Colab, Pix to Pix HD, checkpoints. Or actually, sorry, this goes into datasets, and then waves 2021. And so by default, it is going to start with the very last frame that is inside test frames. And I believe that is either 59 or 60. 60. So it's going to start with this frame. So by default, if you don't set the start frames, it's always going to start with this frame. So this is still getting a little bit of time to set up. Once it's set up, it'll start to actually render each individual frame. So while this takes a little bit of time here, I'm going to get set up and actually change what my start from frame is. So I'm just going to go in here. I'm going to set these back to 240. I'm going to set this back to, what did I say, 100 before? Let's just set it to whatever. And now I need to pass in start frame, takes in a file path. So this is what's really important. I know people get mixed up here because start from takes a path, and then there's a start from before or start frames before, something like that, that other people are trying to use. I'm not going to cover that here. If you're interested, I can talk about it more. But that takes in an integer. So just know that like one takes in a path and one takes in an integer, and that can be kind of the challenge. So I'm going to go ahead and grab a different frame. So you could start from the very, very beginning. If you just came in here and picked up frame 1, you could start from that frame and just sort of see like from the very beginning, does it learn this? What I'm going to do is I'm actually going to take from a later frame. So test frames only ever contain 60 frames. Because the way this model was set up by default, it starts at 60 and then always goes from there. But you can start from any frame. So I'm going to come in here and I'm going to pull, let's do 120. So I'm going to copy the path from here. I'm going to paste that in. So remember, this should always point to a path. Now, this doesn't have to point, as I showed before, it doesn't have to point to a frame from your data set. It could point to a frame from, or an image from somewhere else. The only thing is that the size of this frame or the size of your image has to match what your model expects, right? So I believe this is 1280 by 720, which means my frame has to be that size. So if I were to take another frame that was 640 by 260, it would throw an error message because it doesn't match up. So just know that if you're going to get really crazy and play with different frames, that the frame size it matches what it expects to see. So as you saw, this was generating. We'll take a look at these videos in just a second once I run this command. But it will build up all your frames, and then it'll say that your video is ready, and it'll give your video a name. It'll say how many epochs it is and how long that video is. So before we check that video, why don't I run this one? So this is going to start from a different frame, but it'll be the same epoch count. And one more thing I'm going to do is I'm just going to set so Mackenzie, I'll take a look at this because I saw that you were getting issues with that. So I'll take a look at that maybe later tonight and make sure that's working correctly. Okay, so zoom level. So zoom level is set with a pixel amount. So remember, this is how many pixels in every frame you crop in. If you set this to like really high number, like 300, it's going to be like hyper tunnel vision. If you set it to something less, it's just going to like feel like the model is changing a little bit more. So some of your models will feel like they actually get stuck somewhere where they just like keep repeating the same image over and over and over again. This is a good tip to use that might just sort of keep your model moving. So sometimes models get stuck in an area where they're just like endlessly repeating the same image back and forth. This can help fix that. So just be aware of that. So I'm going to set these to be 240 again. I'll set this to be 100, and we'll use the default. So I'm going to run this. And so those videos will be inside of your checkpoints, your project name, and then output. So if you double click into output, you'll see I have a bunch of other videos here previously, but the epoch 100s are the ones I want to look at. And you will see I've got one that just says 10 seconds, another one that says 10 seconds. And this one says it started at frame 1020 or 120. So let's watch this one really quickly. If it will play. So there we go. Because it's a little early, it's a little noisy. It's not like, it's not showing a ton of detail. And if we go to this one, so I have to compare those two side by side, but I feel like I got a different result from this one. I feel like and even just seeing the output, I'm getting a different result. And again, that's because of this sort of chaotic system because of where it starts, right? So it starts much further into the wave. And I get a lot more of these sort of like, I don't know, webbed patterns instead here. So it's worth playing with. I will admit that sometimes this feels like endless. You could play with these like with endless different combinations and get different results. And if you're a hyper perfectionist, you may struggle with this model because you'll feel like you're never done, and you'll just want to keep looking and keep trying different things to find an even better result. And it may not be there. So don't overexert yourself trying to find the perfect version of this video, but do play around with those results. So I'll play the zoom level one, or I'll drop the zoom level one in Slack for people. But I think we should probably take a break now. So why don't we do sorry, go ahead, Atri.
Yeah, so I have a question on NFP wise. So that works on video to video? Is it like every time for every unique video we are supposed to train Is it like that, or we can have a trained video or trained model, and we can inject other videos and get the projection or something?
Yeah,
How it generally works?
yeah, I generally find that you need to train per video.
Ah,
Yeah, so it's per video, and unless you're training for a really, really, really long time, like 1,000 epochs, it will generally, like I showed, it will quickly devolve into like other movement, or back to your old frames very quickly. So that's one of the challenges with this is that it does take a while, or like you do have, there's no sort of generalization for all video. There are some other models that try that, but I also find they don't look as good. But yeah, you do have to train per video.
thanks.
Mhm. Okay, cool. Let's take a quick break. So let's do 8 minutes if we can. So let's just come back at 8:20. That way we can pick up and keep working on some of these other things. Sound good? Okay, see everyone in 8 minutes. Mackenzie, first off, I figured out that issue and I will push a fix up tonight, so it should work again. Sorry, I know this has been like a 3-week long process of getting this fixed. Yeah.
Thank you so much. I
Yeah, of course.
really appreciate it.
Not a problem. Cool, so let's take a look at the zoom level before we move on to Munit. So here is our video with zoom. So you can kind of see it, right? It does that like zooming in effect pretty quickly at the beginning there. So I'll save these out for folks if you want to watch them again, but this one does appear to be working. So that's cool. Any other questions about NFP before we move on to Munit?
I have a small question. Is NFP only on Colab, or do they have a version on Runway?
Yes, this is another thing, is there's no version of this on Runway because Runway only produces single image outputs. So there's no concept of video or feedback loops inside Runway. So unfortunately, NFP is only available on Colab.
Cool.
And likewise for Munit, Munit is only trainable on Colab. And I think I have a version of the model that can be imported into Runway. So if you do train it and you want to like use Runway for inference, you can, but it's not for the light of heart. It requires some coding and other things. So wouldn't recommend it unless you really want to get into it. So yeah, so that's sort of what's nice about these two models is, or like maybe that's bad, is you can't use Runway for these two. All right, so let's take a look at Munit inference. So remember that Munit and next stream prediction are kind of similar in that they both they both take images as inputs. The difference is that NFP is kind of by default, like assuming you want to use the video input on it as itself, whereas for Munit you actually have to say like, hey, use these images as inputs. So in this case, we're going to feed an image into our model. I'm going to particularly feed this image in, and you'll use the -- input command. So the -- input will always point to a file, again, a file path. Remember, the reason we might want to use Munit over Pix2Pix, or sorry, over CycleGAN, is that it can generate more than one image based on one input. And that is using this numStyle command. So numStyle, if you pass in 1, you'll get 1 image. If you pass in 10, you'll get 10 images. So you'll see here's an example of me passing in this image and a bunch of different outputs I got. I think this is 6 or whatever. So there's also a command, I'll probably skip over this, but if you're interested in using it, I can show you how to I believe it's in the notebook already. You can pass in an input image and then also a style image, almost like style transfer, except it's not really like style transfer, but you can guide an image with your output. So basically you say like, I want to use this as my input image, and I want to use this image, and I would definitely recommend that it be an image from your dataset you already trained on as your input. So like, I don't know what would happen is if you gave it a different style image that it had never seen before. Honestly, I have no clue what would happen there. maybe it's something you want to try. But generally, you want to feed it a image that has been seen in your data set already. So in this example, I got this image out, and you'll see it doesn't really it didn't pick up this this pink or these like teal images. It did pick up sort of the reddish thing, and then I guess it picked up the two reds, and I guess somewhere in here the gray came through. So again, this isn't perfect, but it's a way to think about it. Moises, your question about is num style output similar to vectors in a latent space? Yes, it is. So num style is essentially a vector, and we pass in essentially a seed, a random seed value, and that gets passed through as a vector. So you can animate this, which I believe might be the next thing. Yes, here we go. So there's a way to use interpolation, which we'll talk about much more with StyleGAN. But in this case, what we're doing is we're saying, here's my input image, and instead of a discrete style number, like 1, 2, 5, we're saying, actually animate between 1 and 2 and 2 and 5. So we'll cover this a lot more when we get into StyleGAN, because interpolation is like pretty much all you do with StyleGAN in many ways, but you can do a little bit of interpolation with this, which is kind of interesting. One thing to note is that your like base image is more or less static, right? You're not really animating this image. You're just animating sort of the texture on top of it. So it's different. It'll feel different than StyleGAN. And now there is a way to do video with this. It's hacky because what you're really doing is you're giving it a series of input images. Like basically all you really do is you break your video up into individual frames, and then you feed every one of those frames in using test_batch.py, and then you give it the same sort of interpolation values. So one thing you'll note is that unlike StyleGAN, which has a very smooth animation, these CycleGAN and Munit models, the animation is not smooth. There's a little bit of this flickering quality. It actually reminds me of Kelly's risograph images, where like there's just sort of like, there's a little bit of flickeriness because of some noise in these models. So just know that you can't really get super clean animations, but maybe that's cool. You get sort of this like old school sort of animation style. But this is pretty cool. That's what makes Munit a little bit more interesting than CycleGAN. Like CycleGAN you literally give it an input image, you get an output image. You can't really do some of these like animation things, which are probably what makes it a little bit cooler. Okay, so I again have sort of already within Munit set up my notebook here. So I believe I've already mounted this. I don't think I've run this yet, so let me just do this. And again, you probably don't need to run this. I haven't updated any code in any recent time, but if you want to run it, you can. Let's see if this does anything for me. I might regret that because it might take a minute or two. But yeah, these are essentially batiks. Yeah, I was doing a lot with textures and pattern and that sort of thing with this particular model. All right, so nothing really updated there. That's fine. So we're going to skip the training stuff because we've already trained our model, right? So now I want to look at testing. So when you run test, there's a couple of things you need to do here. So first off is you probably have already made this YAML file, right? So if I go into my drive and then go into Munit, there was already this config file you made. Now the truth is you don't need to touch this because you've already set it to all the right settings, but just make sure the file is there, because if you've deleted the file, then you will have to find it again or remake it. So don't delete that file, it was my hope. So you will pass it the config file, which you probably already have set above in your test or in your training. And then you will give it your an input image. So in this case, I just went through my data set, which is what I had trained it on, and just grabbed one of these images from here. So I think when we talked about training, I recommended that you just duplicate your train and test files, which is all I've done here. So I just gave it a path to one of these files. One thing to note is that if you have stuff like parentheses, like I did in mine, you'll have to do this thing called escaping parentheses, which means putting forward slashes in front of your characters. A better thing would probably be to just to rename your image to remove those parentheses and then just use that path. That's hackier, but much easier and cleaner. So you'll feed it an input, and then you'll say where to stick it. So you're going to stick the output here, and then you need to pass it a checkpoint file. So just like before, we were kind of passing it like what that epoch file was. Here you're going to again pass it a path to a checkpoint file. So in this case, when you go into Munit, and again, do this in Drive because your checkpoints won't show up because Colab is weird like that. Inside of results, nope, not inside results. Where is this here? Instead of outputs. Yep, and then in there, there's checkpoints. So again, in this case, you're going to have to pass it one of these files. Now this is going to be a little bit tricky because in Munit, you can't look at these, you can't look inside that folder and grab that path. So it's usually just going to be /outputs, whatever your project name is with folder, checkpoints, and then you can usually just copy and paste the file name itself here. If you're into issues with this, let Lear I know and we can help you with this. And then lastly, you pass an A to B of either true or false. So remember that Munit learns both directions. So if you want to go A to B, which is the way you probably trained it, you say 1, which is equals true. If you want to go the opposite direction, you set this to 0, which equals false. This means it's going to go B to A. So I'll just run this cell. And this should be pretty quick because it's just processing one image. So Lee, how I knew which files to pull were just the files that I edited. So usually, like if I update something, I'll let people know which files I need to update. I did get a V100 this time, right? Yeah, okay. Being slow no matter what. Okay, that ran. So if I come over here and I go to my outputs, and I go into my, let's see, what should this be called? I believe it just might be this one. Yeah, so it's a little hard to see, but this is the input from this. So, so that is how you do single image testing. If you want to get multiple images out, again, remember this is how we talked about num style. So what you're going to do is you're going to pass it, you're basically going to use the exact same command, but at the end you're going to add num style. So this is how many images do I want. So let's say I want 20 images. And then num style start, you don't really need to worry about this too much, but let's say you produced images 0 through 20, and then you want to do another 20. This would be the start of this. So if you've ever used, we'll talk about this more when we do StyleGAN, the idea of a seed value, this equals a seed value. So this will actually start at 85, or this will start at 65 and go to 85. Don't worry about this too much if you don't worry about it. But basically, if you've already produced 20 images and you want another 20, you'll want to set this to be to start at 20 and then produce another 20. So when I run this, my folder should just fill up with a bunch of output numbers. And what I kind of like about this is that it will fill up with the output and the seed value. So this will be, you know, it'll be, yeah, so see it produced, interesting, what did it produce? There we go. So it produced 20 through 40 here, or 20 through 39 because it's 0 based. But it also gives you the input, so you can sort of look and see at what each of these values are. So obviously viewing images inside of Colab is a little annoying. You can double click, or you can just download the image directly. Yep, so there's my image. All right, so I'm going to skip over guided translation, but know that it's just pretty much the exact same, except for your style image, you pass in dash dash style, and then you give it a path to an image. Again, and I recommend that this, if you're going to do A to B, that you pass in an image from your B set. If you're going to do B to A, your input should be a B image, and your style image should be an A image. That's kind of confusing to discuss. As you get the hang of stuff, I think it'll make a little bit more sense, but just know that depending on what direction you're going, you also want, if you're trying to do guided style, you want to make sure that where you're guiding it to is an image that it's seen before in that data set. Again, these are good things if you have questions about this to come to co-working sessions or ask in Slack, and we can help with that. And lastly, I'm going to skip over the batch testing. If you want to do a batch test like video production, like let Lear I know and we can help with this. But I'm just going to quickly show how to do interpolation between styles, because I want to spend the last 20 minutes of class going through style again. So for this one, it's pretty much the exact same command. You are giving it a test.py, you're giving it a config, you're giving it your input image, and then I'm just going to set an outputs of video-test. You are passing at the exact same checkpoint. And then you are saying dash dash interpolation. So if you don't ever add anything after one of these dash dash commands, that just means it's true. So we're going to say, yes, we're doing interpolation. And then we're going to feed it a series of seed values. So those seed values match with whatever these outputs are. So one thing I recommend doing is generate a bunch of different images. So you could do, in this case, like let's say you want to generate like 200 images. Generate these, download them, look at your favorites, and pick out your favorite numbers. So in this case, for whatever reason, I really liked the first seed. I really liked 99. I really liked 9, 50, 25, and 0. So these are like essentially keyframes in your video. So these will be the points that you are animating between. So I'm going from image 0 to image 99, and I'm doing it in a number of set frames. One thing to note, this is where it gets a little tricky. Whatever number you set here, you have to set your num style to be at least that big. So because I have here, I've got this to set to 99, I have to set my number of styles to be at least 100. This is like some math that goes on behind the scenes. If I were to set this to 199, I would need at least 200 styles. I should probably just automate this, and maybe I will in the future. But for now, just know that if you whatever your highest number is here, make sure that your number of styles is set to basically like 1 plus that. And then how many frames? So this is how many frames we want to produce out of that. So basically like if I have 1, 2, 3, 4, 5, 6. So if I have 6 total keyframes, or yeah, keyframes essentially, 720, what does that math equal up to? So that is, it's gonna be 140 frames, 144 frames between each key point. So again, this will not be a video. The line after will convert it to a video if you want to. I'll do some better documentation of what this should say, but just know that this will generate a bunch of frames. So it'll generate 720 single images, and then you could download that and bring it into like QuickTime to generate a video or something, or you could run this cell below here to turn it into a video using FFmpeg. So I'm going to set this to be really short just so you can sort of see what it does. So this would be 40 frames between each one of them. Yeah, maybe that is this note right here. Maybe it should be bold, but yeah, I did add that note here.
Okay. For some reason, what you said wasn't what I interpreted that to mean. But
Yeah.
anyway,
yeah, it should almost be like, let me rewrite this. So it should be num style needs to equal the largest value in seeds. Is that clearer?
Yeah, totally.
Okay, great. Good
Instantly-
feedback.
Okay, thanks.
Yeah, no, because I agree. That was definitely weirdly worded. So as this runs, it's just going to produce a number of images. And if I go to my outputs video dash test, you will see here that there are a number of images being generated. Now, when this stops, it will, I guess I'm at 159. So this is going to just keep outputting until it hits 200. If you want to just generate a video really quickly from this, the way this ffmpeg command works, and there's a whole bunch of stuff to know about ffmpeg, but essentially all you need to do is pass it the path to the folder and make sure your name is correct. So what we're going to do here is I'm just going to go to this folder, copy the folder path. So we'll copy this folder path. And what I recommend you do is don't edit the actual like PNG number. Just edit the path and replace that and add a slash. That's because this is automatically generated to match whatever the file output is. So this will just know. All this is saying is look for a sequence of 3-digit numbers after this output.png. So this tells you how to it learns how to sequence the numbers. So just run this cell, and then you can also give it a path to an output video. So when you run this, it'll just generate a video. You will see, I often use this, I believe, well, we used to use it more in the StyleGAN notebook, but I automated a lot of that away. But you'll often see this ffmpeg command. We didn't really talk about ffmpeg in this class, but it's kind of like a cool utility for everything video. I should probably teach like a 5-week class just on ffmpeg because it's pretty intense. But mostly if you just replace that path, it'll work. No, so Moise is just the output names. This output, the file name is just automatically generated. So when you run this video command, it'll always start with output 0, output 000, and just that way it knows to always look for this this file convention. So this will download a video. So basically, while we switch between Leah and I'll drop this video in the Slack channel for anyone to check out. So that's Munit. I know we went through that quickly, although I think so far I've only heard Steven is using Munit. If other folks are using Munit and you want to talk about this more, I'm happy to do a little bit more of a deeper dive into this. But I want to make sure that we have a little bit of time to cover StyleGAN. We'll cover a lot more StyleGAN next week as well. So we'll definitely have a lot of time to cover StyleGAN. But I'm going to hand it over to Leah now.
Sweet. Okay, let me share my screen. Actually, I'm gonna share my entire screen. So when I play the videos, y'all can see them. Okay, yeah, StyleGAN. Before going into how to do inference on StyleGAN, I'll give you a little bit of a rundown of latent space, which is some background knowledge that's important to understanding how, sort of how StyleGAN works, how all of the internals work, and how inference works. So within StyleGAN, let me get my pointer. There's a thing called a latent space, and you can imagine the latent space as this space. In this case, it's drawn as a 2D space of these points, and each point in the latent space, when you pass it through StyleGAN, when you do inference, then it generates the corresponding image to that point. This point you can also think of as a vector. It's sometimes called a latent vector. So one latent vector or one point in the latent space corresponds to an image. And different points will correspond to different images. And the nice thing about StyleGAN is the fact that if you have 2 points in the latent space that are really close, then the corresponding images will also be very close. So you can see they're almost the same image, but with some slight differences in the hair and the bangs. And think there's, oh yeah, interpolation's a bit later. But yeah, one thing to know is like here it's illustrated as a 2D grid for our, puny human brains. But Stalgan in reality, like, instead of each one of these points being specified as like an XY coordinate of like 1, 2, for example, each one of these points in the real Stalgan that we're using is specified by 512 different numbers. So yeah, each one of these points is just a vector, a latent vector of 512 different numbers. And yeah, those will correspond to different seed values, which Derek covered a little bit already of, but we'll go into a little bit more detail. So in terms of inference, when you're trying to actually generate images, what's literally happening is you're saying, here's a random latent vector, and I want you to generate the corresponding image. And that's what happens during inference. Inference has a bunch of different names. It's also known as evaluation, also known as testing. But what it really is just generating new images from your trained Stalgan model. So with that, I'll just kind of pop back and forth between the notebook and the slides. This is the same Colab notebook that you use to train. Like there's NVIDIA SMI, connecting your drive, installing the repo. And we can skip over this train model section because we assume we already have a trained model that we want to play with. This bit, for the 2 or 3 of you that did train your model in Runway, you will need to use this cell to convert your model from Runway to the type of model that we're using in this Colab notebook. But for those of you that didn't train in Colab, you can ignore this. And then here, testing inference, aka just generating images from your trained model. This is the cell. Maybe I'll make my text a bit bigger. So yeah, generate single images. This is the command, Python generate.py. Here you specify your out directory. I've just created this folder and I passed it into here as like where I want all of these generated images to be saved. Here, there's a thing called truncation value, which we'll talk about in the next couple of slides. But essentially, it's like a value to determine how realistic the generated images is. Seeds. So the seeds, each one of those points in the latent space corresponds to, that 512 dimensional latent vector. And seeds are a way that we can specify specific vectors without having to like type out 512 different numbers. So like these are just integers that just point to different random vectors. So like seed 2 and seed 5 correspond to 2 different 512 dimensional latent vectors. And one thing to know is that even though these are integers, they're not really ordered. They're just random seeds. So they might as well just be named as like seed A, seed H, seed J. They don't really have an order. And here I'm telling it to generate seeds 0 through 50. So this will go through and generate seed 1, seed 2, seed 3, all the way up to 51. And it'll spit it out in this folder and store all. I can actually run this now. And then it'll store them in this folder as 50 different images. And then here at the very end, this is an important bit where you pass in the path to your trained network. If you've been training your model, if you go to your Google Drive and actually I can just do it from Colab. If you go to Colab SG2 ADA PyTorch, your models will be stored in the results folder. And I'll grab the latest one, which is this one. And I'll grab this path. And then that's the path I would stick in here. My network is named this. It's a very long path. Yeah, so I would just network. It's a little annoying. Yeah, network equals, and then the path to your network. And so this is like, if you want to generate 50 images, you know, have this as 0 through 50. If you want to generate 100, you can do 0 through 100. And these generated images, they'll be saved out to the file that you specified in your out directory out here. So I've saved these. I've decided to save them to my Google Drive, but they are here. Generate images and then seed 0, blah, 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 all the way up to 50. And if we click on any of these, we can see what random seed 46 looks like, which is this. This is a model I trained on some Chinese paper cuts. Yeah, and if you want, you can zip this folder and download it and flip through the seeds and look at ones that you like or dislike, which will come in handy later when you do interpolation. Yeah, so that is how you generate, like literally just generate images from your model, static images. The next thing, or the next little bit, is on truncation. If you noticed over here, we had to specify a truncation value, which we had as 0.8. What this truncation value means is it's a floating point number, like a decimal number that corresponds to how realistic, like similar to your training data set that outputted images are. So one specific outputted image corresponds to two things. First, your random seed, like random seed 13, for example, and your truncation value, which in this case we used 0.8. And so, yeah, truncation value is basically how realistic the outputted images is. And because it is, you know, this decimal number, we can scrub along it and use it to make animations. So this is starting from a middle truncation value, which is, you know, this is the most normal average face in the Flickr faces model. And as this video goes on, we're changing the truncation value and moving it to a higher extreme value. And as you can see at the, like it starts off pretty normal, but then deteriorates into kind of monster looking like images with less realistic outputs. But this is still with the same random seed. So you can think of truncation in terms of the latent space. Well, the reason why it's called truncation is because it literally like truncates the latent space and like, yeah, kind of like closes it within this box. Derek, do you have anything to say here? I always get a little bit confused when it comes to this.
So one way I would describe this is imagine that like your best produced images are toward the center of this model, and the weirder images are are like toward the edges of these models. So like what truncation does is essentially it sort of like truncates the space to be like whatever your value is, it sort of truncates it to the more realistic images. In general, like the thing to remember about truncation is the lower your number is or the smaller it is, the more realistic your images will be, but the less diversity you have. So it just sort of changes the diversity amount because you can sort of, again, see like there's less options to pick from around the edges. So you get more of the stuff in the middle but that means, if you don't set your truncation value to 0, because if you set to 0, you'll get the exact same image every time because the space is so small. There's literally just that one image. So don't set it to 0. You will be disappointed. Most people set theirs between 0.5 and 1. So the truncation video that Leah can show you will sort of like show you how it differs. Your truncation value can be negative. Don't ask me to explain that one because it doesn't make sense in the human way. Just know that like mathematically it could be negative. And it kind of works the same way. Like if it's negative 0.2 or negative 0.5, it's going to feel like pretty realistic, but like this essentially flips the space in a weird way. It's very confusing. But just know most people usually set it like in the positive 0.5 to 1. But you can do all sorts of weird things with it if you want to.
Cool. Thanks. So yeah, next portion of the notebook is on truncation, making these videos or animations, basically, starting at one truncation value and then like scrubbing up to a different truncation value. So here, it's the same script, generate.py, but we're telling it we want to do truncation. Here you input the path to where you want this video and the frames saved out to. Yeah, I've just created this folder, truncation traversal. Here you can pick what start value of truncation you want to start at. So maybe I want to start at 0 and then go up to 2. This increment value is basically what each frame takes. So this will start at 0 and then go to 0.02 and then 0.04 and 0.06 all the way up to 2.0 for the truncation value. And this is all on the same random seed. So if I went over to, if I went through all of those frames that I generated, I could go through and pick a specific seed that I liked. Like here, I decided that I liked seed 14, and then that's the one I picked that I wanted to use for this video. And then again, I'm just passing in, you would pass in the path to your pre-trained network. And then, yeah, just running that will save it out to the output directory that you specified. So I've already done this and put this here, and I'll share that video right now. We can watch what it looks like. Open truncation. So this one actually started at truncation -1 and goes up to 2. So it starts negative and then passes through 0 and then goes up to 2. So yeah, at the edges, it's kind of like there are all these weird colors and artifacts. And then also on this extreme end, on the very end, it kind of like blows up. Yeah. The very next part is interpolation.
So Leah, real quick, we
Yeah.
only have 3 minutes left, so why don't you just show how to do one animation, and we can pick up on the difference between Z and W next week, because yeah, I think I've got some. Yeah, we'll cover that next week, but I want just for this week, maybe it'd be fun to just generate some video.
Right. Yeah, that sounds good. Yeah. So for interpolation, you have this nice latent space. You can scrub between 2 of them. And basically what you do is you specify keyframes or seeds. And if we go down to linear interpolation, same thing, tell it where you want it to be saved. Here, there's one for Z space and one for W space, but I won't go over that right now. Same as before, you put in your truncation value. And here, this is the part that you have control over. Here, you can pick which seeds you want it to interpolate between, like in these keyframes, and then it'll go ahead and interpolate between them. A nice trick if you want a looping video is you can make the start frame the same as the end frame, and then you'll have a nice looping video, and then the path to your pre-trained network. And then also there's this frames parameter to control the number of frames on each of the legs of the interpolation. So running this, it'll go ahead and generate that. But I can go ahead and just actually show it. So this is interpolating between four different seeds and then returning back to seed 0. Okay. And that was in Z space, and I have one more. It's the same seeds, but in the other space. But we can talk about that next class.
Yeah, so I would say, go for it. Oh, maybe that was just feedback. So I would recommend walking through this notebook. So we'll have the recording up later tonight. Walk through each part of this. If once you've generated some videos, later parts of the notebook show different ways to generate video and other things. So you might want to just like keep walking through it. We'll cover a little bit more of this next class just because we did run over a little bit. So I think David had already just walked through like the entire notebook and just like started generating a bunch of stuff. Once you sort of get a hang of just like assigning like, okay, this command takes in a pickle file, this takes in a seed, the rest of the notebook might actually make a little bit more sense. So I'd just say start with the things Leah showed, and then if you are feeling adventurous, move into the other areas in the notebook and you might find some cool things. And if not, we'll cover more of it next week because I think there's so much you can do because of these are just mathematic points in space. There's so many different things you can do with them, and we'll look at a bunch of different things you can do next week with that. So there's lots of cool things to play with, but I would say just get comfortable like assigning seeds, changing parameters like truncation value and that sort of thing in the notebook, and then next week we'll have even more fun with it.
Mm-hmm. Yep. Yeah. So your homework is to just have fun making videos and images in Colab. And then I'll send out some more details about our final show and tell, but it'll be fun.
So I just had a question about, are all of these GANs? And they are all GANs. They're just slightly different in the way the architecture works, but these three models do all have a generator and a discriminator. Yeah. Munit actually has, I think we talked about this maybe a couple weeks ago, but Munit has 2 generators and 2 discriminators to do that like sort of back and forth system. All right, so unless there are any last questions, just get comfortable with generating images and video, especially through Colab, because it's not the quickest feedback process, right? Like we're used to just having like move something in Photoshop and you can see it, where like GUIs can like sort of immediately respond to you, and this takes there's a little bit of lag time. You have to sort of like make some stuff, look at it, try to figure out what it did, then input some new things in. So it's like it just takes a little bit of time to get used to that process. So I definitely recommend this week just like play with just generating lots of images. If you haven't trained your data set, maybe you want to do a little bit of that while you're generating images from a data set you have. Leah and I can also post, there's a link to there are a bunch of like sites that have pre-trained models. So if you also just want to play with someone else's model while you're training your own, you can do that. We'll send some links out to places to do that. All you'll want to do is like download the .pkl file from those sites. You have to use that legacy cell that converts it to the PyTorch version, but it should be, yeah, we'll send out links to it and then some explainers, and hopefully if you haven't trained a model yet, you can play with that, because I think StyleGAN, you'll begin to see why so many people use it as we jump into new topics and new categories, because it's just really flexible. So next week we'll look at some touch designer stuff. I'll finish up this notebook. We'll look at how to do feature vectors, which are like, how do you make someone smile using these models, those sort of things, and maybe whatever else fun we can jam into an hour and a half. So yeah, we'll see everyone next week unless anyone has questions. Okay.
I actually have a quick question. It's
Yeah.
a dumb one.
No, it's fine.
Leo was referring to the frames as seeds. I don't, why was that? Like, they must be distinct from animation keyframes then.
Not really. I mean, there really are keyframes. Essentially, you're basically saying like, this is the main thing I want to animate between. When we get into other animation types, there are no keyframes, and we're sort of we're doing like a circle in the latent space. So a seed, I mean, the way to think about a seed is that a seed is a placeholder for a 512 dimensional position in the space. So that's sort of the hard part is people want to say like, oh, I always will, like, can I reverse engineer my place in space to a seed? And that doesn't work. You can start with a seed and find that space, find that position in the space, but you can't go from like, I know the position in the space, what's the seed value of it? It's like purely mathematics stuff. But yeah, I generally refer to them as seeds when they are, but they are essentially keyframes when you're doing animations with them.
So they're keyframes, but they also have a vector, right? Which is like some coordinate within this latent space.
Yeah. Yep. We'll cover a little bit more about vectors and latent spaces more next week when we get into also like how do we manipulate those spaces, like feature vectors and some of the animation types. Like if you play along further in the notebook, you'll see there are like different types of loops that you can generate. And those are almost like auto-generated. You don't provide much of anything. It just sort of generates a loop in that space. Again, because they're like a dimensional space, you can imagine like just creating a circle in that space or like doing some like crazy twisty thing. Because it's just a space, you can think about it almost like physically how you move through it. Yeah. Any other questions? Okay. We'll also be doing co-working sessions again this week. So if you do get stuck somewhere, first off, please just drop a question in Slack. Lee and I are happy to answer it when we can. And if you can attend a co-working session and want additional feedback, let us know through there. Sound good? All right. We will see everyone next week for the last week of class. Bye, everybody.
Bye, everybody.
Bye.